All right, good afternoon, everyone, and welcome. So as many of you know, this is part 4 of our 7-part series on big data, the power of large observational data sets. In an effort to address this broad, important topic, each workshop and seminar will highlight a unique aspect of big data issues, applications, and challenges. So among the topics to be discussed include big data for outcomes research, using big data for dissemination and implementation science, machine learning, and today, data linkages. So there is a sign-up sheet out in the hall, so hopefully everybody had a chance to sign in. And we are collecting evaluations after each of these seminars, so please complete the evaluation so that we can get feedback to be sure that we're meeting your needs and get feedback about future seminar series. So I'm delighted to introduce our speaker for today, Dr. Toan Ong, who is an assistant professor in the Department of Pediatrics here at Anschutz. He has a PhD in computer science and information systems and has extensive experience in applying computer science methods in solving biomedical informatics problems. In his active focus in addressing issues in data quality and identity management, he has developed a number of novel approaches to solve problems related to missing data and improve data linkage performance. He has also notably collaborated with researchers and developers at the National Data for Autism Research, Chicago Area Patient-Centered Outcomes Research Network, and Colorado State University. He is also a key member in the technical team in the Safety Net project, of which Dr. Lisa Schilling is the PI and Dr. Michael Kahn is the informatics lead. Currently, his research interests are record linkage, data de-identification and encryption, schema mapping, data mining, and natural language processing. So help me welcome Dr. Ong. We're excited to give talk. Thank you.
Thank you, Beth. Hi everyone. Again, my name is Toan Ong, and I'm in the Department of Pediatrics. So about a week ago, Kelly reached out to me, saying that there's a cancellation. So would you fill in? So I said, okay, yeah, I will fill in, but not sure that I can entertain the audience. So you're not gonna probably see what you expected before you came here, but I try my best to make it helpful. Just to provide a little bit of additional background about how my involvement in this topic. So I joined Safety Net in 2012 as a postdoc, and I was tasked with linking Safety Net clinical data and Medicaid data. And in that work, I basically developed a method, adapt to a data linkage to do that, to do just that. And so developing from that experience, I was asked to participate in a number of research data network, such as PITSNet or PITScanner, to basically, doing record linkage. So for today presentation, I will start quickly. I think it's going to be helpful to start with some background about record linkage. And then, share with you about the linkage exercise that we did, in PITSNet between Express Scripts and St. Louis children via the Washington University. And then, look forward to the another exercise that we would like to do in PITSNet, and that is to link data from Colorado children and the Philadelphia Children's Hospital. Also, at the end, I would like to talk briefly about, the visions for the D2V record linkage projects, which I'm leading. So, a very quick definition of record linkage. What is record linkage? So record linkage can be simply defined as the process to link records, in one or many data set, which belong to the linkage. The records belong to one individual. So that individual can be a patient or a provider, right? And because records usually, are usually scattering across multiple data sets, oftentimes these data sets are owned by one institution, but they can also be hosted, at different institutions with different environments, different server. To link record in those scenarios, you need to share data across these participating institutions. The other day, a student asked me why. Why do you need to do data encryption before you link the record? Can you just use a standard data sharing, secure data sharing method to send data from one place to another, and then do linkage on the clear text data? That is a very naive but very legit questions. Because not the problem is that not that you would try to secure the data during the transferring process, but also to make sure that the data are used properly, and the partners in the linkage process will only use the information for linkage, not for any other purposes. So because of that, we need to protect the privacies of patients' data, and that leads to the definition of privacy preserving record linkage, and that is the process to perform record linkage without revealing the patient information. So there's two main objectives of record linkage. The first objective is to deduplicate data. So for example, if you have a clinical data set, that data set can be hosted at one institution or multiple institutions, and you try to make sure that each patient only appear one time in that data set. The objective is to basically try to link that data set with itself and make sure that all the duplicates records will be accounted for. The second objective of record linkage is to enrich the data, right? So when you do research, one data set might not have all the information that you need to carry out your research, to do your data analysis. In that case, you probably want to reach out to external data source and potentially try to link these data sources together to bring patient together, patient data together in one place, so you have a richer data set. Sorry I didn't mention, so please feel free to interrupt and if you have questions. We have time for question at the end, but make sure that ask the question. It's okay to interrupt. Okay, so this is a very generic diagram about a record linkage process. This diagram was presented in the tutorial by Kristen and Verikios. So every time I include this diagram in my talk, it makes the audience understand the process a little bit better. So I just do it here again. So Kristen is a very well-known researcher in the record linkage area, and he's in Australia. So Tel actually met with him, and hopefully one day we can bring him back here to go to Denver and talk about his work. So in this diagram, you can see that there's two source data sets, A and B. These data sets will be pre-processed I will go into the detail of each step in this diagram in this presentation. But very quickly, the data will be pre-processed and then will be grouped or rearranged in a way that they will be linked together in the comparisons process. And then basically when the records in two data sets are linked together, the linkage will be classified into three different buckets. As you can see, the red, the low right red boxes, three buckets. The first one is matches, the second one is non-matches, and the third one is potential matches. And then these buckets will be evaluated and reviewed. So now we're going to go into the detail of each of the steps here. Okay, so let's talk about source data. One of the problem of record linkage is record linkage can be a very trivial process if you have shared universal identifier among the source data sets. But unfortunately, that usually, that information usually doesn't exist. So instead you have to use other demographic information about the patient to link. Like I list here, first name, last name, DOB, social security number, gender. And then, I saw people using, visit information, visit date, provider, NPI to link records. And, they, to a certain degree of success, they can actually do that. But, these are the most popular variables to link. These variables can be used as individual variables or be concatenated together in a certain way to perform the linkage. So if you link data in clear text, then it's not necessary to create the combination. As you can see, the reason for creating this combination is to potentially increase security. So for example, when you, I will talk a little bit about data encryption later, but it's going to be harder to figure out the clear text value of the linkage variables if you can you combine them together that way. So this is just one example. People been using their different combinations for linkage. Okay, so in the data pre-processing step, linkage data, the variables that I saw earlier are standardized, through a series of steps. So I listed out a number of basic steps here. For example, you make the names all lowercase or uppercase, and you remove all special characters, dot and space and different thing. Asterisk in their name, and then do some phonetics encoding to make sure that there's to make sure that if there's typos in the name, then they will be basically standardized. And then we can also perform name standardization. People use a different abbreviation, in their names, and then nickname standardization. So if people use nickname, then for the linkage to be successful, you need to basically convert that nickname into a full name. And then missing data standardization. So one null value or an empty string in a data set can be presented in a gazillion ways, right? So one data model have one convention for presenting null values or empty string. The other one have different ways. So if we can basically So why is this important? This is important because let's take social security number for example. So if you have a social security number of 9999909, right, and then another person have basically 999999 in their social security number. If you compare these two social security numbers, they are 100% matches, right? And that is a false represent of the full evaluation of the similarity between the two values because they both missing. That doesn't mean that they are the same. So we better recognize the missingness of information in these linkage variables. Yeah, so so this is a very interesting problem, and yet they have conflicting results. Some people told me that this is this step alone decide the overall performance of your linkage method, and then another paper told me differently, right? So this doesn't do anything for you, right? And then if you standardize your data too much, it will even reduce the specificity of your data, and it's lose the uniqueness. It takes away the uniqueness in your data set. So the Pew Charitable Trust actually put out an RFP, and we submitted but got rejected. So from the conversation with them, he told me, I don't know if he was nice or not, but we came in second maybe. So they interested in knowing if data standardization will improve the performance of a linkage method, and just for put out an RFP just for that part. So it's important. And data pre-processing also involved data encryption, right? So in the PPRL context, the privacy preserving record linkage context, data will be encrypted or hashed before it got sent to another partner or a linkage party or an honest broker. So I put down here a method that we have implemented in our tool, and it's called the Bloom filter hashing process. The basic idea of this hashing process is to basically, because when you try to link data in the using encrypted data, it's very hard to hash the entire linkage values. So for example, if two names have just one character difference, when you hash these two names, you will get completely different encrypted values, right? Even though the differences between the two names, just one character. The idea here is to create the tokens, right? So for example, in this example, the token being being bigram strings, right, up to letters. If you tokenize the value down into bigrams and then hash the bigram, when you compare the two values, not the entire values that got compared, but the bigram will be compared. In that case, you kind of hope that the overlapping at the bigrams level will indicate the similarity, the relative similarity between the two text values. And what? Could you tell me what hashing? Oh, okay. So sorry about that. So I put here. So hashing here is a one-way hash. It's a method to basically turn a clear text value into a random string, and it's not ever possible to go from that random string back to the clear text value. And it makes sure that when you hash to exactly this similar clear text value, you always get, the same random string. And when the data got converted into the Bloom filters, you use the dice coefficient. Basically, it's a method to compute the similarity between two Bloom filters. Okay, so far we've been going from the data, the linkage variable, go to the data pre-processing. Now I'm talking about indexing and searching. So the part you see here will be done at the site in the privacy preserving context. Okay. Should probably go a little bit faster. We're running out of time. So what do we do in the indexing and searching step? In that step, basically, you try to partition your link, the records into different blocks, right? So because if you link two data sets with a large number of records, and basically try to compare each record in one data set to all the records in another data set, the efficiency of that process is very very bad. So the objective here is to divide the records into different blocks and then link the record within the blocks only. The benefit of doing that is it will significantly reduce the number of comparisons for the entire linkage problem, but also because potential, correctly linked records got assigned to different blocks. In that case, this also will increase the probability of false negative linkages. So that's why when you select a blocking variables, you have to select a variables that you're pretty sure that records in the blocks, that are linked together will have these same values. For example, if you use like birth month to block, then your data will be partitioned into 12 blocks, right? And the records within each blocks will be compared each other instead of comparing everything. Okay, so so how do you know if a blocking method is good? So there's two measures for that. The first one is called recall, and that is the proportion of the true matches that the block preserves, right? So if you block and you don't basically increase the number of false positive, and then the reduction ratio, which means that how much of the search space that got reduced by as the result of blocking. All right. The next step is to link and to compare the data. So there's two famous methods, in this for this task, and that is deterministic linkage. And for example, on the screen you see here, the linkage variable got compared directly with each other. Even one tiny, difference between two values will result in a non-match. And the second method is probabilistic matching. And in that case, each variables will have different contribution to the similarity score between the two records. So for example, the thickness of the arrow represents the contribution of that variable in the problem. So for example, gender, as you can see here, has a very minimal role, but first name, last name have a more important role in the linkage process. This is a very, very generic formula to compute that similarity score or math score I've been referring to. And that math score basically is computed by the sum of the weight, the thickness of the arrows here, and the individual similarity between the two values in the particular variables. And when you get, get that match score, you basically will compare the match score to a threshold. And in this two class classification, you will compare to one threshold, and if it's larger than or equal to that threshold, then the linkage will be considered a match. Otherwise, it will be a non-match. In the case if you have three classes, as we saw in the diagram, you have three buckets, right? You have match, non-match, and then potential matches. So in that case, you will have two thresholds: the high threshold and the low threshold. So if if it's higher than the threshold, then you can say outright that these linkages are matches. And if it's lower than the threshold, then they are non-matches. But if it's in the middle, then these are potential matches. So we need to do more verification to confirm. The thing is, it's very easy, not easy, but it's fairly straightforward to do that in the clear text linkage space. But if you use encrypted data, it's a very hard problem, and we'll talk briefly about that later. And then the linkage performance will be evaluated by different things, right? The number of true matches, or precision, or recall, using this formula. Or you can use one harmonized number, as that is the F measure, basically combining precision and recall to evaluate the performance of a linkage method. All right, so verification. How do you know if your method performs well enough? There are three ways to do it, as I listed here. The first one is to use synthetic data, because you generate the data, you know which record link to each other. You kind of know that, but we got hammered by many reviewers for using synthetic data. I personally see really the benefit of using synthetic data, because first of all, we know the correct linkage result. Second of all, we know we can control the the data, right? So for example, if you want the data to have more typographical errors, then you can basically do that. The second one is the gold standard data set. So for some reason, you can obtain a verifiable linked data set. Then you can use that to compare the performance of your method against that gold standard data set. So for example, we've been talking about using the Choreo ID as the gold standard, but again they are using another method. So we invented the term of relative gold standard, right? We have our result, they have their result, we compare the two results together, and then potentially manually review the discrepancies between the two of the result coming out of the two methods. And the third way to verify do verification is to perform manual adjudication, to have a human sit down in front of the clear text data set, and then basically compare the two records manually. And again, it's probably a problem when you perform encrypted privacy preserving record linkage. So to talk briefly about PITSNet, some of you here are very familiar with the network. So PITSNet is a PCORI funded clinical data research network, and it has 8 members institutions, children's hospital across the US. So the model of PITSNet is that it has a data coordinating center sitting at a job data center, and 6 out of these 8 hospitals send the data to the job DCC. And entirely, PitsNet have a 5.14 million patients across the US. Okay, so our long-term vision in PitsNet is to bring all the data from all member institutions to the CHOP DCC. And the CHOP DCC will act as the honest broker that link these data together, these data sets together. But to do that, first of all, so there's two things. The duplication, we can link the patient among PitsNet partners, and then enrichment by linking PitsNet data with other additional source of data. And so the exercise I'm talking about here is that second part, right? To enrich PitsNet data. So St. Louis children is among one of PitsNet members. So and they volunteer themselves to participate in this exercise. So the two data sets we are trying to link in this experiment is to link Express Scripts data, which is a pharmacy benefits management company, link with clinical data in the St. Louis children's data set. So we divided the testing into phases. The pilot phase using very small data sets, to set up the tools, to train the staff and things like that, and then carry out a full test. We did obtain an IAB protocol separately for both of the tests. In the pilot test, we created a small data set of 404 records from St. Louis Children's, and then because Express Scripts have more than 80 million members, so we have to extract, create a small data set out of that 80 million data set using two variables. First of all, the 3-digit zip code, and then the birth year of the patient. So using that to create a small extract from the Express Script dataset, we got roughly 600,000 records. In the full test, we link the entire St. Louis Children's dataset with almost 80,000 records, and Express Script again, a small extract to that will match that St. Louis Children dataset with 9.2 million records. So I'm not sure this is qualified for big data, but it's not. I know it's not, but it's kind of big for a linkage problem. For data, so for data preparation, we remove things like prefix, suffix from the names, remove space, special characters from the names, and then capitalize all the text. We did encrypt both data sets using the CU linkage tool, and that is the curl tool that I've been advertising around the country. So this is a tool that got developed based on another tool, another open source tool. So this tool is also open source, and we encrypt the data using the Bloom filters, the concept that I presented earlier. So the process is to use deterministic linkage method using 5 variables. First name, last name, I think date of birth, gender, and then zip code to do deterministic linkage. And use that as the baseline performance to compare to. And then we perform PPRL probabilistically on the encrypted data set, and then examine the linkage results. So step number 4 here is to verify linkage result using clear text data, and we'll talk briefly about that later. So the result of that small pilot test is we were able to link 238 linkage I'm using the deterministic linkage method, and then 255. That that's a pretty good number for probabilistic. And because this is just a small these are small data sets, we were able to sit down. So myself and another technical person at a scratch script actually sit down and review all of the linkages resulted from this activity. And what we found was that there's typos in the names, in the in the date, and then there are nicknames that got used because we didn't have any nickname standardization in the data preparation step. People use maiden name, and then there's prefix, suffix that that we could not remove from the data. So this is the result of the full test. So again, we link 78,000 records in St. Louis children dataset to 9.2 million records in a scratch script dataset. And then we used, as you can see here, we used three different blocking schemes, right? So the first scheme is to use 4 initial letters of the last name and the year of birth. The second scheme is 2 initial number of zip code and month of birth and date of birth. And the scheme 3 is the most aggressive scheme, and is to use the syntax of the last name, initial letter of the first name, and the entire date of birth. Okay, and so this is basically the result. The number you see here are the threshold that I was talking about. So we use 0.85 as the lowest threshold, for accepting, for determining a linkage. So on the left-hand side here, you see that if you use scheme 1, blocking scheme 1 alone, you will get 39,000 matches out of 75 records. That's the pretty good. So the way to read this basically these numbers is that first of all, you need to identify the scheme that have the worst performance, and that is scheme number 2 with the threshold of 95. So 95 is pretty conservative, right? So you allow minimal number of errors in the data. So if you use scheme 2, and the scheme 2 is right here, and the threshold is 95, in that case you will get about 31,000 matches, linkages, out of the data. And scheme 1, apparently, the performance of scheme 1 is very promising. It's better than, it's like 8,000 more than scheme 2 and this. So the result here is very expected, right? So when you within the same scheme, when you increase the threshold, the number of linkages decrease. I'm sorry. As you can see on this row here, and that is the case for all the schemes. Because if you just use one blocking scheme, it's possible that linked record got assigned to different blocks. So it's a good idea probably to basically combine the linkage results of these different blocks, right? So for example, if you combine the linkage results of scheme 1 and scheme 2, you get a little bit more, out of the linkage that got identified with scheme 2, but not in scheme 1. And then, if you combine scheme 1 and scheme 3, then you get, different results. The one that use the most linkages, as you can see here, is when you combine. When I say combine, I mean union, right? You union all the linkage results from scheme 1, scheme 2, and scheme 3. Of course, it's gonna be less efficient if you add more blocking scheme into this table. But if the cost is manageable, and and your schemes are the variables, the blocking values that you include in the scheme are different from each other enough, then it's worth a try. It's, at least to our experience. Okay, so linkage verification. How do we do linkage verification? So honestly, we are still in the talk of how to carry out this work. Again, this is PPRL linkage, privacy preserving record linkage. So and there's a certain level of trust between Express Scripts and St. Louis children, so they are willing to allow the adjudicators. We think about using 3 different students to verify, look at the data on both sides and determine if it's a legitimate linkage or not. And then we will randomly create a random sample based on the math score that we got from the full test, and then potentially put together a list of linkages of linkages that the students will then verify. So I have 10 minutes left. Let's so I want to go quick so we have some time for questions. So this is another exercise that we want to do, and that is to link Colorado and job data. The process here is very similar to what you saw. Clear text linkage at each institution will be hashed into bit string into the Bloom filters, and then send to the linkage, the process, which will happen at the job GCC, and then the linkage process will generate random network level identifier and send that to the participating institution. But the verification process, the red box here, becomes very complicated in this situation, because the institutions are willing to share encrypted data, but not clear text data, as in the previous experience, exercise. In that case, so we still, contemplating about how to perform linkage performance verification in this work. Talk quickly about the vision for D2V record linkage project. So as of today, as I know, there's no one national institution that that is willing to raise their hand to basically to be the honest broker of the record linkage work in the US. And I kind of hope that I want to push UC Denver toward that position. There's a reason they didn't want to do it, right? But as a young investigator, I still have the enthusiasm to push for that, and then be able to provide record linkage as a service. When people come to D2V with a record linkage need, then we have the ability to to change or to accommodate their requirements for their particular linkage need. And then for the research agenda of D2V, we will develop flexible, effective, efficient, and secure linkage methods. So in summary, record linkage is not a simple problem, simply because of the 3 things I listed here. Very large amount of data we have to link, data error in the data, and the problem to make the linkage process secure, and And then, so the challenges that we usually see in a regular linkage problem is the availability of linkage variables, different type of attack, on the hash data. There's usually no gold standard link data for you to evaluate the performance of your methods. And then it's very difficult to perform linkage verification, as because of the need to share clear text data. We got funding from other different funders, but AHRQ and PCORI mainly. And then thank you so much for the SETINET team, PITSNET team, and the D2B team for this work. Right, thank you. Questions? Yes, sir.
Why would you think that there'd be that much overlap between CHOP and Colorado?
Yeah, that's very interesting question. So so patients follow their providers, and especially in rare disease population, and somebody sitting at the CHOP institution did actually query the zip code that starts with 8, and they found, like, I think a couple thousand people that in CHOP data from Colorado. So the objective here is to figure out the process, not necessarily the population, but how, because we are thinking in a long-term vision, we are thinking about doing this for the entire PITSNET network. So it's an exercise to figure out the process to share data and perform.
What will be the challenge when the OPAIR claims data be ready to link with electronic medical records here?
So the claims data, which claims data? I'm sorry,
OPAIR
can you?
claims data.
OPAIR claims data, or APCD? Yeah.
I heard this month.
Okay.
Some taxpayers receive APCD data.
So I happen to lead the record linkage group in Compass also, and right now we are relying. So we will link that APCD data, but I'm not sure if APCD will send the data to Korea. I'm not sure about that, but if they do, then we will, like I said, do our own linkage. So Compass has been receiving death data from the CDP-HE, and then so they use a software to link data, and they send data to Compass. So my task is to verify if their linkages are correct. So in addition to the death information, we've been requesting for the demographic data, for the linkage also. So we will also run our own linkage methods and then compare to their linkage method. The pitfall of that process is that we are limited by the linkage that they provide, because what they give us already, the performance of their method. So but at least we can tell if there's any discrepancies between the two results, linkage results.
Is there, it seems like part of the difficulty and issues that there's not necessarily a standardization as far as data collection goes, and there's different models that are being used by providers. Would this eventually lead to a standardization as far as collection goes, and or the sharing of information? My understanding there's not at this point, but it seems like that would be something that would be helpful.
So the question is, will the data collection process be standardized just for this? For not just for this money, but for this work, for the linkage work. I certainly hope so. There's a lot of missing data incorrectness, in the data that make this problem hard. But if there's a way to say that, okay, if you have missing data or certain criteria that we can follow to ensure the quality of the data being collected for this process, then it's we certainly welcome that. But apparently that's not the case. So you can ask a Google user to type Google keywords correctly all the time. Any other questions? 2 minutes.
Can you go back to your last figure?
So the idea, I'm sorry. The idea here is for each institution in their behind their firewall, hash their data into bit strings, and then send the bit string to the honest broker. Again, this in this case it's a job DCC, and the job DCC will perform the linkage, send the PITSNet level ID back to the institution along with the original random ID, so they can associate that back to their data, and then also include the mask score. Okay, so what's the mask scores for in this situation? The mask score is for the verification, right? So the buckets of linkage that we're gonna verify those buckets are defined based on the mask score. So in production, you probably don't need that the mask score to be returned to the institutions.
So I was trying to think of what has to be agreed upon by the two institutions before this is done, and is it the variables that will be used, the sequence of variables, and the buckets?
Right. So we're still in the middle of that process, but this is, so like I said, standard, not standard, but most popular variables are first name, last name, DOB, gender, and zip code. However, and social security number is out of the picture because of the poor, the high missingness in the pediatric population. So we have to, but now we have to sit down and talk to children about the possibility two questions: sending hash data. Is that okay? If we can do that, then can we carry out the full scale verification using clear text data? And what needs to be in place for that to happen? Okay, I think that's it.
Thank you so much.
Thank you.
Thanks again, Tom. Really appreciate it.
Institutions that hash it for you.
Yeah, but then the institutions say,
Thanks, Chase, too. Trying to find that.